Okay, so here's the video on numbers 11 through 20. This one says the hand on the circular clock in the figure below measures 10 centimeters. So the hand is 10 centimeters. Which of the following is closest to the distance that the tip of the hand travels as it moves from the 7 to the 12? So it's going to move from the 7 around to the 12, and we want to know how far it travels. That's arc length. So our formula for arc length is degree of our arc or angle over 360 equals x or arc length over circumference, which is 2 pi r. So I need to know the degree of this right here. Well, I know the whole circle is 360 degrees, and this has 1, 2, 3, 4, 5, 6 sections in this half. So if I divide the 360 by 2, half of the circle is 180, and there's 6 parts to that. So 180 divided by 6 is 30. So each one of these little divisions is 30 degrees. So from the 6 to the 7 is 30 degrees. From the 7 to the 8 is 30 degrees. So I have 1, 2, 3, 4, 5 sections. So the 30 degrees times 5 gives me 150 degrees total for this central angle here from the 7 to the 12. So the 150 goes in my degrees over 360 equals x times 2 pi times r, which is the radius, which is 10. So I cross multiply, and when I cross multiply I get 360x equals, when I multiply all of this together, I get 9,424.78. Now I divide by 360 to solve for x, and I get that x equals 26.18. We're dealing with centimeters, and since it's arc length, it's just centimeters. So that is my answer. Make sure that you can cross multiply and get the answers that I'm getting. A corner of a park has been set aside for a flower garden. The park's fencing has a shorter leg of 40 feet, and the length along the longer leg is 96 feet. And I want to know how much more fence do I need to completely enclose it. So how much fence do I need to go from here to here, basically? So that's an a squared plus b squared equals c squared, a Pythagorean theorem problem, where this is c, this is a, and this is b. So 96 squared plus 40 squared equals c squared. 96 squared is 9,216. 40 squared is 1,600 equals c squared. We add those together and we get 10,816 equals c squared. To get rid of the squared, we take the square root of both sides. So we get c equals 104. And our units are 104 feet. So we're going to have 104 more feet of fencing that we need. 5 spheres are being painted for display at a store. If the diameter of each sphere is 9 centimeters, which value is closest to the total surface area that will be painted? Well, the total surface area of a sphere, the formula is 4 pi r squared. So we look here, we have a diameter of 9, and I need a radius. So 9 divided by 2 is 4.5. That converts my diameter into a radius. So now all I do is plug in my numbers. Area is 4 times pi times the 4.5 squared, and when I plug that into my calculator, I get 254.47. Now that's for one sphere, but it says here that I have 5 of them, so I need to multiply that times 5, and I get 1,272.35, and my units are centimeters squared because it's area. Oops, skipped one, go back to 14. This circle has a radius of 4 centimeters and a central angle with a measure of 36. What is the area of the shaded sector? So this is an area of a sector problem, and our formula is similar to our arc length. Degree over 360 equals x, or area of the sector, over the area of a circle, pi r squared, instead of the circumference. So my degree is 360, or is 36 degrees, sorry, over 360 equals x over pi times my radius is 4 squared. So when I cross multiply, I get 360x equals 1809.56. Divide by 360 to solve for x, and x is equal to 5.03. My units are centimeters, it's area, so they're squared. 15. Given the following sets of Pythagorean triples, identify the next set of numbers if the pattern continued. Well, the pattern from here to here is to multiply by 2. 9 times 2 is 18, 40 times 2 is 80, 41 times 2 is 82. Then from here to here, we're multiplying times 3. 9 times 3 is 27, 40 times 3 is 120, 41 times 3 is 123. So my next step would be to multiply those times 4. So 9 times 4 is 36, 40 times 4 is 160, and 41 times 4 is 164. So that is my next set of numbers. 16 says if BC equals 6 and CE equals 8, then the possible lengths for segments AC and CD are. Well, this is a circle where we have two secant lines inside the circle, and our formula is PP equals PP, or part times part equals part times part. So I look at one of my segments, and one part of that segment is 6 times 8, and the other side has to equal the same thing. So these two segments have to equal the same thing that these do. So 6 times 8 is 48. So whatever I put over here also has to equal 48. So my options are 1 times 48. So I could have 1 times 48. I could have 2 times 24. I could have 3 times 16. And I could have 4 times 12. Because all of these, when multiplied together, give me 48. So any of these options would work for that answer. Kevin's teacher gave him, oops, wrong direction, the following pieces of cardboard. We have 2 equilateral triangles and 4 squares. So which polyhedron can Kevin build using some or all of the pieces? Well, we know that we're either going to have a prism or a pyramid because those are our only choices. So for a prism, we have 2 bases and 4 rectangular faces that connect them. For a pyramid, we have 1 base and, or however many, maybe not 4, but we have rectangular faces, and we have triangular faces. So we would have 1 of something and then a bunch of triangles, depending on how many sides there are. So we know we don't have a bunch of triangles and just 1 of something else, so the pyramids are out. So 2 bases, and then we need rectangular faces to go with them. So if we use the 2 equilateral triangles as our 2 bases, then we could use 3 of the squares to connect the 2 bases. So our answer is a triangular prism. A triangle is enlarged by multiplying each of its dimensions by 3. That should tell you right there, multiplying the dimensions by 3, that we have a scale factor equal to 3. Based on this information, which of the following statements is true? So one of 3 things is going to happen. We should know this by now. If we're looking at our new perimeter, our scale factor is still going to be 3. If we're looking at area, our scale factor is going to be 3 squared, which is 9. And if we're changing volume, it's going to be 3 cubed, which is 27. So we look here and everything says we're increasing the perimeter. So our perimeter scale factor is the same. So 12 is not right, 16 is not right, 18 is not right, 3 is the correct answer, so we are looking at D. A sheet metal worker needs to cut a piece of metal in the shape below. What is the length of the longest side? If we're given a right triangle, there's two things we can do. We can either use the Pythagorean theorem if we know two sides and we're missing one, or we use trig if we know an angle and a side. So here we do not know two sides, so we cannot use Pythagorean theorem, so we're going to have to use trig. So here's my 90-degree angle, which makes this my hypotenuse. Here's my theta, and 6 is right next to it, so that's my adjacent. So I think back to my trig functions, SOHCAHTOA, where I have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I look and see, okay, I'm looking at adjacent and hypotenuse, so that's going to be cosine. So my formula, and this is on your formula chart, cosine theta equals adjacent over hypotenuse. Fill in what I know. Theta is 72. Adjacent is 6, and the hypotenuse is x. When x is down low, we switch and divide. That's our process when our x is on bottom. So we're going to switch the x and the cosine 72. So we get x equals 6 divided by cosine 72. Make sure your calculator is in degrees when we do trig. And when we plug that into our calculator, we get x equal to 19.42. And the last problem for this section is isosceles trapezoid JKLM is shown below. If the dimensions are multiplied by a scale factor of f, so we know our scale factor equals f, which statement is true? Trapezoid JKLM contains two base angles measuring 30 degrees. We don't know whether that's true. That has nothing to do with the scale factor. The longer base of the trapezoid, which would be here, is 56 f units. Well, that's true because we're multiplying the 56 times f, which equals 56f. So that's a possibility. Let's check our other answers. The bases of trapezoid JKLM have lengths of 22 units and 39 units. How did this get to 22? We don't know what it gets to because we don't know what f is, so that's wrong. Trapezoid JKLM contains two base angles measuring 120 degrees each. We don't know that either. What we do know is the longer base of the trapezoid is 56 f units, so that is B.